Okay guys, now here we are again going to solve another question, and this is also application of work energy theorem. Okay, and we are going to solve this question in very detail, and it is a very good question. Okay, okay, and it is not quite difficult, but there are so many things which we can learn from this question. Okay, okay guys, so the question is, an object which I had written here. The question is, an object of mass m is tied to a string of length l and variable mass variable force f is applied. Okay, this, here this is the force which is shown in picture on it, which brings the string gradually at angle theta. This is the angle theta. With the vertical, find the work done by this force. Okay, so guys, first thing, when you read the question first time, if you are a beginner in Newton's law. Okay, sorry, if you are beginners in the work energy principle, then the first thing which come in your mind is that you try to find out work done by this equation, dw is equal to f dot ds. Okay, vector f dot ds, but here the problem is we do not know what is the f. Okay, we do not know what is the f. Okay, here f is not given in the question. Okay, so you know in first look this question become quite difficult. Okay, because f is not given, and here the ds is not, ds is going to along this path. You have to think there, you have to do so many things. Okay, okay, guys, uh, okay, listen here, this question is going to be lengthy question. Okay, because we are going to learn so many concepts with the help of this question. Okay, okay guys, first let's draw the free body diagram. Okay, first let's draw the free body diagram. Let's draw free body diagram. Okay, so here, this is support, and this is, okay, this is support. Let me wait a minute. Yeah, this is support, and this is angle theta. Okay, and this is the object which tied here, that object is, okay, and okay, 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 just leave it as it is. Okay, and this is angle is theta. Okay, okay, so let's draw the free body diagram. Okay, if you draw the free body diagram, then here this force is the mg, this force is mg. Okay, and here this is the tension T, this is the tension T. Okay, and a force F. Okay, which act on it, a force F which act on it. Okay guys, and the condition is, the basic condition is that that this force it is, this the condition is such that this force is balance it. Okay, because this string, this force bring this thing gradually, at any stand there is equilibrium between this force. Okay, at any stance there is equilibrium between the force. Again guys, so if we know the here this is the tension T, what is the tension T and what is the mg, then we could easily calculate the force. Okay, by balancing it. Okay, because here this is the T, this is the, but here the problem is we do not know T also. Okay, we do not know T also. Okay, we do not know T also. Okay, so it's become quite difficult to find out, to solve the question with the help of this, thing. Okay, because we do not know T, we only force which we know is mg. Okay, so balancing is not going to work here. Okay, now, okay, so let's think. Okay, let's think that there is another method which by which we can solve it. Okay, so guys, let's think about work energy theorem. Okay, let's think. You will just wonder how powerful this statement is. Okay, what is the work energy theorem is, the change in kinetic energy, change in, let me write down, change in kinetic energy ke2 minus ke1. Okay, this should be equal to work done, net work done. Okay, let me correct it, net work done. Okay, net work done. Okay guys, here which force will work on, which force work on this object. Okay, on this object, this mg, gravitational force will work on this mg. Okay, this force is going to work on this mg, and this force also, this tension T is going to work on this mg. Okay, tension force also going to do work on mg. Okay guys, now, and guys, okay, so this is the very important thing. Okay, so we have to find what is the work done by this mg, what is the work done by this, and what is the work done by this. Okay guys, so okay, guys, okay, now let's think, consider about work done by this tension T, work done by this tension, work done by this tension T. Okay, guys, if you look at this geometry, here the length of a string is not going to change, length of a string is not going to change. This means, this arc, this path will be a circle. Okay, think why. Okay, this, this length of this string is not going to change. What is the length here is L, and length here is L, and length at this point is also L. So, this arc, this path will be a, this arc will be a, part of circle, this arc will be a part of circle. Okay, so think why. It's your job. If you are not able to think why. Okay, so, if I say that this is going to be arc of circle, so, if displacement taking place along this direction. Okay, look at my pencil, movement of my pencil. Okay, if displacement taking place along this direction, displacement taking place along this direction, so this angle will be 90 degree at every stand. Okay, why? Guys, you should know the geometry of circle here. Okay, this angle is going to be 90 degree. Okay, at every stand, at this point, at this angle also, let me suppose at this angle also, if this is the displacement, dx2, so what is this angle? This angle will be 90 degree. Okay, so, guys, displacement angle between this tension T and displacement is always going to be 90. Okay, angle between the displacement and this tension T is always going to be 90. Okay guys, so, so work done by tension, work done by tension, or work done by tension force, work done by tension force is going to be by tension force is going to be, dw is equal to f dot ds, guys, and here f mod f. Okay, f dot ds mod f into ds mod of ds into cos theta, and this theta will be 90 degree. Okay guys, so whatever value of this ds and this, it always 0. Okay, so dw is 0, so what is the work done? Work done will be 0. Okay, basically work done is integration of dw, and dw is 0, so work done will be going to 0. Okay guys, so, here work done by this tension is going to be 0. Okay, and this is a very important concept. Okay, you should work on it. Okay, now here, and now we should consider work done by this mg. Okay, work done by this mg. Okay guys, okay, it's your job to find out. Okay, it's your job to find out work done by mg. Okay, yeah, think. Okay, it's your job to find. I'm just going to write down the answer. Okay, what should be the work done by mg. Okay, and okay, just if you are, if you are just in class 11th, then you should work hard to find work done by this mg. Okay, I'm just going to write down. Okay, this is the L, this angle will be L cos theta, so, this height will be L minus m cos. So work done by mg will be minus mg L 1 minus cos theta. Okay, this is the work done by gravity. Work done by gravity minus mg L 1 minus cos theta. Okay guys, now, and okay guys, so okay, so let me clean it. Okay, I'm just going to, okay, I'm going to just erase all these things here so that I could get some space. Okay guys, so what I said that work done is equal to change in kinetic energy. Okay guys, here this word is very important, gradually. Okay, if this force F bring it to this angle theta gradually, this means that at every instant velocity of this block is going to 0. What is the velocity of this block? Velocity of this block is 0 at every instant. So what is the initial velocity? 0. So what is the initial kinetic energy? 0. What is the final velocity? 0. What will be the final kinetic energy? 0. So what is the net work done? Net work done is 0. Okay, so net work done is equal to 0. Okay guys, okay, so so what will be the net work done? Net work done basically work done by earth plus force plus tension. Okay, plus tension, so work done by, and this should be equal to this is the net work done. Net work done 0. Work done by tension is going to 0. Okay, and work done by earth, this is basically minus mg L 1 minus cos theta. Okay, plus force, work done by force. Okay, this is the work done by force, this should be equal to 0. So what is the work done by force? Okay, work done by force, this should be equal to mgl 1 minus cos theta. Okay, so guys, look the power of this, look the power of this work energy theorem is that here we are not going to find force. We do not know what is the force at any instant, but we are able to find out work done. Okay, we can find work done at any instant. Okay, we do not know what is the force here. Okay, so this is the power, and guys, look at how much calculation I had done. I in my whole lecture I just had explained the concept. Okay, I in the whatever calculation you may say that this is the calculation which I had done. So this is the this is just some typical question, but if you think if you're going to approach with work energy theorem, then this become one of the most simplest question. Otherwise this is the very complex. If you are going to find out with the help of Newton's law, then it is one of the most complicated question. Okay guys, thank you for watching.